Section 2, we're looking at arcs in circles. And this will relate to angles as well, so we'll have some stuff in here about angles. It's actually what we start off with. Our central angle, right, is an angle whose vertex is the center of the circle. So if we look here, C is the center of the circle. Angle ACB, right, is a central angle. The measure of that angle is equal to the arc. So the angle here is 50 degrees. The arc is also 50 degrees. Okay, as we go along, we'll look at arcs that doesn't work with. But in this section, the angle and the arc are equal. Write that down. Then we have three different types of arcs. We have the semicircle, right? This is, you're probably familiar with, this is 180 degrees. It's an arc whose endpoints are the endpoints of a diameter. So we look here, it looks like this line here would be, maybe not. We have this coming out as a diameter. And it wouldn't hit D, we'd hit somewhere in here. All right. So when I'm naming that, we would name that with the point we're starting at, a third letter, and the point where we're ending at. Okay, so the name of the, actually I'll look down. We'll talk about that when we get down here as far as naming it. The other two we'll do based on this one. Your minor arc is part of the circle that measures less than 180. That's not. Okay, so for example, AB with that arc over it, that's how we name an arc. That would be this arc here, that's 50 degrees. Okay, also arc BD, which we don't have a measurement for, but the arc from B to D would be a minor arc. Okay, a major arc measures greater than 180 and less than 360. So it's not a full, it can't be a full circle. It's going to be less than that. Okay, so part of a circle measuring greater than 180 and less than 360 degrees. Okay. So an example of that would be if I go from A to D to B. Okay, and again we put the arc over that. Okay, your minor arc normally will be 2 letters. There are some exceptions, but we won't see many of those. Your major arc and your semicircle will always be 3 letters. So the first 2 tell you where you start and end. The other one tells you the direction you're going to. So I know I'm going from A through D to B. Okay. So this is giving us our, find the measure of the arc, where DF is the diameter. So DE, right? We have this arc here. That's 117 because it's the same as the angle. DFE is all of this here. That's everything but the 117. So we do 360 minus 117. and we get that this is 243. DEF, that's our semicircle. Okay, and that's how we would name a semicircle here. We have the diameter, right? So that's just 180. Okay, so anyways, we could ask other things that aren't here as well, like EF would be 180 minus 117, because I know that that is the diameter. Right. Example 2, find the measure of RTS. So I have everything except that 45 degrees. So I do 360 minus 45, and I'll get that that angle is 315. Ooh, you can't see that. Right. Then we have the arc addition postulate. Right, we've dealt with addition postulates in the past. Arc addition postulate is saying if I add two smaller arcs, I get the whole large arc. So arc ABC is made up of arcs AB and BC. Okay, so if I know this is 70 and I know this is 100, then I know this is 170. Okay, and it's just letting us do that. We can combine arcs and then solve. So we look at the top here. All right, we have our pie chart, which is basically, a pie chart is basically using central angles and arcs as we're doing this. All right. So they have our divisions here. We could talk about them as the sections they name them. They just talk about them as arcs. So BD. Right? I have B and I have D. If it's two letters, you're always going around the shorter way. If I go around this way and I add those up, I'm going to be greater than 180. Therefore, that is wrong. So I'm going around this way. I have an angle, I have 55 as a center and 105 as a center. I add those up. BD is 160. If you have three letters, you always go in the order of the letters. So I go from B to C to D. All right, so I'm going around this way. Okay, that's going to be 140 and 60 that I'm adding. That's 200. BCA, I start at B, I go around to C, and then go all the way up to A. So there's two things you can do here. Actually, you can add up all the three that are there. You would also subtract the one you don't have from 360. Either way, when you do that, you get 305. And then ABC, right, I'm going here, so I'm looking at these two. Add those up, and we get 195. Okay. And the last thing here is on congruent circles and congruent arcs. So two circles are congruent if and only if they have the same radius. Okay. Congruent arcs, right? Two arcs are congruent if and only if they have the same measure and are in the same or congruent circles. You just realize when we talk about this arc up here being 55 degrees, that's not an actual measurement of that. That's looking at how much it is out of that full 360. Okay, it's not a length. If I'm going to go to the stool, if I'm going to make a pool, I'm not going to say the pool size is 360 degrees. Right? So when I'm looking at covering the deck, I'm not looking at measuring that as 100 degrees. I need an actual foot measurement. Eventually we'll get to looking at how we do that. But right now we're just dealing with the degrees. So it's not actually a measurement. The one circle could be a lot larger than another, so that 45 or 55 degrees would be different. Okay. So example 4 is looking at what we look at here. Right? It says tell whether these are congruent Why or why not? So B, C, and D, E, they're both 75, right? And they're in the same circle. So this would be congruent, right? They're the same circle. And measure. Okay. When I look at B, all right, both of those are 80 degrees. AB and CD are both 80 degrees, but the circles are clearly different sizes. So this would be no, because I don't have congruent circles. Okay, and then C, all right, this would be congruent, right, because they're both 90, and I have the dash in those radii, meaning those circles are congruent. Okay. I'm not sure we mentioned that in the last video when we talked about radius. The plural of radius is radii, right? So, same degree, same measure, congruent circles would be my explanation. Okay. And that is our introduction to arcs and central angles.